Alright, here we go with the vectors unit. This is going to be the entire vectors unit in one video, hopefully. So first one, we got to find the components. Components are the coordinates of this. Draw a quick sketch of where we're dealing with here. We're dealing with a vector 105 degrees, start at 0, 90, 105, magnitude of 5. We're looking for those coordinates. Those coordinates are called components. It is the magnitude times the cosine, magnitude times the sine. Remember, it's like the unit circle, cosine and sine of the angle that we're looking at. 5 cosine 105, 5 sine 105. Make sure your calculator is in degree mode. So let's check the mode. It is in degree. Here is your calculation. Negative 1.29 comma 4.82, and that makes sense because we're in the second quadrant, negative, positive. Alright, now we've got a vector made up of two components, a and b. 3, negative 1, so you go over 3, down 1, there's a. B is negative 5, 6, back 5, up 6, somewhere like this. I want to go vector BA, so I want to go from B to A. So if you were to slide this down to the origin, it's going to end up down here in the fourth quadrant. Alright, so from B to A, BA, you're going to subtract A, 3 minus negative 5, and secondly, you're going to go, so you went 3 first, negative 1 comma, minus 6, not comma. So that I end up with 8 in the x direction, down 7, which makes sense. That's where that vector would be if you slid it down. Given subtraction, W minus V, just subtract the components. W, negative 1 comma negative 4, V, negative 3 comma 5. You're subtracting, so just go ahead and subtract them the way it says to. Negative 4 minus 5 is negative 9. Negative 1 minus negative 3 is plus 3, that's 2. These absolute value looking things mean it's a magnitude. So first you got to multiply and then take the magnitude. So first let's multiply V by 2. That's going to be negative 6 comma 10. Multiply 3 times U. That's going to be 6 comma 12. We're going to add those together. 0 comma 22. Take the magnitude, which is the square root of your x's, square root of your y's. So let's see, 0 squared, 0 squared plus 22 squared. So it's the square root of 22. Magnitude 4.69. Dot product, so we have the dot product here. We're going to go U dot W. Dot product is a little different than multiplying because you do get a scalar. So you're going to take your V, negative 3 comma 5, dot that with your W, which is negative 1 comma negative 4, multiply your x components, multiply your y components, and add them together. So multiply your x's, you get 3. Multiply your y's, you get negative 20. Add those together, you get negative 17. Two vectors are perpendicular to U, or a vector that is perpendicular to U. So perpendicular, the other word for that is orthogonal. And if it's orthogonal, it means it's going to be have a dot product that gives you 0. So let me move this out of the way. And I need vector U. So when I dot product U with something, 2 comma 4, dot some x and some y, has to give me 0 for an answer. Alright, so it says a vector, so I can choose either x or y. It really doesn't matter which one I choose. There's going to be a whole bunch of them that are going to work. So if you just decide, okay, I'm going to make x be 1, you can make y be 1, you can make it be 2, anything you want. You got to set one of these up because it just wants one that is perpendicular. So you're going to multiply, so 2 times 1 is 2, plus the 4y, give me 0. 4y is negative 2, y is negative 1/2. So one of them could be 1 comma negative 1/2. It could be any combination. So you could have chose x to be anything, you could have chose y to be anything, as long as when you multiply and add them, you get 0. The direction angle of u, so let's take u. u is 2 comma 4. Remember, the direction it can be found by looking at the components. If we know the magnitude times the cosine of the angle, or the magnitude times the sine of the angle, I can find the angle for either one of these two. It doesn't matter which one. So I need the magnitude first. That's going to be the square root of 2 squared plus 4 squared, which is the square root of 20. 4 plus 16. So the first x component is 2, and that's equal to the square root of 20 times the cosine of the angle. So let's find the cosine of the angle. So I just type in the arc cosine of 2 divided by the square root of 20. Gives me an angle of theta that's 63.4 degrees. So we got next. Find the angle between two vectors. Alright, the angle between two vectors, I need u and v. So let me go back up and grab u and v. 2, 4, negative 3, 5. 2, comma 4, negative 3, comma 5. Alright, so that formula is cosine of the angle is equal to u dot v divided by magnitude u times magnitude v. Dot product u dot v, 2 times 3 is negative 6. Negative 6 plus 20 is 14. Negative 6, 20 is 14, divided by magnitude of u is the square root of 20. Magnitude of v is 9 plus 25, 34. That's the cosine. I don't want the cosine, I want the angle. So it's going to be the arc cosine of this answer. So if you do it in one step, be very careful with parentheses. I'm going to do this in 2 steps. 14 divided by parentheses for the denominator, square root of 20, times square root of 34. 25 and 9, close those both. Second cosine of the answer, 57.5. Again, that's a formula you will need. Next one, same thing. 2, 4, negative 1, negative 4. It's the cosine of u dot v, magnitude u, magnitude v. Even though you're looking at u and w, doesn't matter, make that a w if you want. Formula is the same, so dot product, negative 2 plus negative 16 is negative 18. On the bottom, magnitude of u, you have the square root of 4 plus 16 is square root of 20 times the square root of 1. 16 is 17. Negative 1 squared is 1, 16, that's 17. So we were to take 18, negative 18, divided by parentheses, square root of 20, close that, square root of 17, close that once, twice. That's first part. Second cosine of the answer. So this angle theta, 167.47 is the angle between those two. Alright, eliminate the parameter, which means we have to get rid of the t. Get rid of the t. You've already solved for t, so I'm going to take this where it says t and plug y in anywhere I saw t. So here it's going to be x equals 2 times y squared minus 1. That has eliminated the parameter. Identify the parametric curve. It's a y squared, so this is going to be a parabola. And it happens to be a parabola that opens sideways. I'll eliminate the parameter for the second one. Doesn't matter which one of these you solve for t in, but just solve for t. Solve for t for y here. This is going to be y minus 3 is equal to half a t, but you don't want half a t, you want t, so you have to multiply everything by 2. 2y minus 6 is t. Plug that back in. X equals 3 times 2y minus 6 minus 8. That's going to be 6y minus 18 minus 8. 6y minus 26. Looks like a line. Alright, next one. Find the parametricized equation of a line through. Alright, so this you're going to go, what happens, how do you get x, how do you get y? Where do you start, how do you go from there? So I'm starting with my x, I'll start with negative 3. How do I get to negative 8? Well, I'm going to go down 5 for some t. My y, starting with negative 6. I'm going from negative 6 to 5, so that's going to go up, total of 11. So it goes up 11 every time step. Of the line that goes through that, same thing, x equals, where do I start, how do I go? I'm going down a total of 3 for every time. Y, I'm starting at 5, I'm going down 1 every second, or every moment of time. Alright, I'm going to stop here. I'm going to pick up on the next one because this one, the next one has the breakdown of every single step. So look for this next sheet of paper, which is going to look like this. Alright, so you should have opened up your navigation notes. That's what it's called. Open up navigation notes because these will walk you through step by step for what you need to do when you have these navigation, or we did tug-of-war type problems. They're all basically the same, but it has the steps to solving these problems. So first let's go ahead and draw what we're dealing with here. We have our coordinates here, so it's heading. Remember, headings are a little funny because headings start from due north. They start straight up. So 40 degrees is going to swing out 40 degrees that way. Like that. 90 miles an hour is the magnitude. The wind force is heading at 170, so it's going to be 90. 170 is going to shoot this way down here. This is 170 degrees. 65 miles an hour. The resultant vector is going to be connecting those two. So remember, if you do tip to tail, you slide this wind, because the wind is acting on the end of the airplane, so you can imagine the wind is blowing this way. The resulting vector is going to be somewhere over here. This is the result, because you take from the tip of one to the tail of the other one, so that's where it ends up. It says draw the resultant vector from the initial point of the first vector to terminal point of the second vector, so that's where it's going. Resolve each vector into its components. So what does that mean? Get your coordinates. You always need your coordinates first. So let's pull up my calculator again. We've done this kind of thing before. We're still in degree mode, so I'll clear up the screen. So it's 90 cosine of 50. 57.85. 90 sine of 50, 68.94. That's the first one. That's your plane. Now you got to do the same thing for the wind, or it's vice versa. Either way, you got to resolve both of them. 65 cosine 280, 11.29, 65 sine of 280, negative 64.01. So those are your components. The components of the resultant vector are the sum of the components of the two vectors. Alright, so let's add those together. That's what that means. So 57.85 plus the 11.29 gives me a result 69.14. Sorry about that ding dong. Next, 68.94 minus 64.01 is going to give me a 4.93. From the components, find the length that will be the final speed. So the length is going to be the magnitude. The magnitude of this, which is the square root of 69.14 squared plus 4.93 squared, 0.14 squared plus 4.93 squared. It's the square root of that answer, square root of the answer. 69.32. The tangent of the angle of the vector is the y component over the x component. Find the angle. Alright, so it says the tangent of the angle is the y component, 4.93, over the x component, 69.14. Kind of like the slope, kind of like the trig. Find the angle. Alright, so we have to find the angle, so we're going to do second tangent. So move this all the way up. Second tangent of 4.93 divided by 69.14. 4.07. Look at the diagram again. Decide what the heading must be, knowing the angle of the vector. Remember, the angle of the vector is measured counterclockwise from the positive x-axis, and the heading is measured clockwise from north. What does that mean? It means that this angle that we're talking about here, that we just found, is measured from this position here. So it's a 4-degree angle. But when we measure from headings, headings are always from due north straight up. So this is going to be down this way. So if we want to find the heading, you're going to go 90 minus 4.07, which is 85.93 degrees is the heading, which should match what we were thinking about when we went way up here. It's going to be somewhere in here. The result is going to be in this area here. It's kind of hard to tell when you just originally draw the picture, but that's where it ends up. And how fast is it going? That's the magnitude, 69.32 at a heading of 85.93. So when you go back, use these same notes, this same idea, to do this problem here. You do the exact same thing. for those two. So follow those notes for that that last one. That'll help you with 10 and 11. Alright, that's your vectors unit all in one nice neat place. Only about 20 minutes.